In the previous video, on the same subgroup containing rho sub 0 and mu sub 2 of the group D sub 4, we're able to find all of its left cosets. Here, this time, we are going to find all of its right cosets and probably add some discussions as to whether we have the same left cosets and right cosets of the same subgroup on the group of D4. Now take note that D4 is a group containing all permutations of S4. So we have there this KD's table with which could tell us the operations, but the results of the operation. But this rows here, the rho sub 0 to rho sub 3, these are actually just the rotations of in a permutation. Our mu's are actually the reflections against the perpendicular bisectors of the sides, and our deltas are actually the what you call this one, the reflection or the flipping against diagonals. So let me change my color here to white to illustrate this first. Okay, so our subgroup here, as mentioned, is rho sub 0 and mu sub 2. Let's label this as H in the meantime. And our G is our D sub 4. Take note that D sub 4 is not the set S sub 4 with 4 elements. D sub 4 has 8 elements. This because it contains all the 8 permutations. Okay, so in the previous video, again, we were able to determine the 4 left cosets. The number of left and right cosets of the same subgroup on the same group are actually the same. So we are also expecting here 4 right cosets. But to illustrate, the number of cosets can be determined by the index of H in G, where H is this subgroup and G is D sub 4, denoted by this notation G of H, which means we simply take the order of D sub 4 and divide it with the order of H. Order means number of elements. There are 8 elements on D sub 4, and there are 2 elements on our H. That's rho sub 0 and mu sub 2. So again, we're expecting 4 cosets. This is the same number of cosets that we were able to determine in the previous video. This is also the same number of right cosets. But the question right now is, since we have the same number of cosets, do those left cosets similar, or are these right cosets just similar to those left cosets in the previous video? Now we are going to determine it later and add additional discussion as to whether the reason behind they are the same or they are not. So let's start with the right cosets. The right cosets is actually in this notation HA, meaning we are going to operate our H, which is a subgroup containing rho sub 0 and mu sub 2, with A, where A are all elements on D sub 4. So we have 8 elements of D sub 4, the 4 rhos, 2 mu's, 2 deltas. But out of those 8, only 4 cosets will be determined. We're also going to talk about it later. In general form, we have this form here, H, A, where H are all elements of our subgroup H. So we will come up with sets when we operate all the elements of our H together with an assigned A, which is an element of D sub 4. So let's start with this. If A is the first element of D sub 4, which is rho sub 0, meaning the first right coset is H rho sub 0. Okay? H rho sub 0. So we have here the first result. So we're going to operate both of this. So rho sub 0 times rho sub 0 here. So rho sub 0 times rho sub 0. The result is rho sub 0. Then mu sub 2, because we start with H here. Mu sub 2, mu sub 2 somewhere here, this here. And rho sub 0, the answer is mu sub 2. So it's just the same as H, but this is already our first right coset. Okay? That's the first result. Let's have the second right coset when we use the second element of D sub 4, which is rho sub 1. This means it's H rho sub 1. Okay? So H, the first element is rho sub 0. So rho sub 0 and rho sub 1 is rho sub 1. Next, we have mu sub 2 and rho sub 1 here. That's actually delta sub 1. This is our second right coset. Our third right coset, let me change the color here to black, is determined if we're going to use now rho sub 2. So we have h rho sub 2. So our h, again, let me rewrite here if the spaces will not be enough later. Okay, so I have here h is rho sub 0 and mu sub 2. Okay, so we're going to operate this 2 with rho sub 2. So rho sub 0 and rho sub 2 is rho sub 2. And mu sub 2 and rho sub 2, that's mu sub 1. So we already have the third unique right coset. Now, we only have one more because we have 4 all in all. But we still have 5 more elements of D sub 4. Let's check. If our fourth is rho sub 3, that means it's h and rho sub 3. Okay, so let's start with rho sub 0 and rho sub 3. That's rho sub 3. And another element of h is mu sub 2. You would see that there is a pattern here. We're using only these rows. Okay, we have mu sub 2 and rho sub 3. So you have delta sub 2. So we're already done with the fourth one. Okay, let's check if the next one will be a different if we're going to use mu sub 1. That means h mu sub 1. Okay, so let's start with our rho. This is the first element. And mu sub 1. That's mu sub 1 because rho sub 0 and mu sub 1 is mu sub 1. Next, mu sub 2 against mu sub 1. Rho sub 2. So rho sub 2. Okay, this is the fifth right coset. But why is it that it's not counted using the index of h and g, where h is the given subgroup and g is d sub 4? I would like you to compare these two. This is the third right coset using rho sub 2, and it is the fifth right coset using mu sub 1. But if we're going to examine the results, okay, we have the same elements of the set. This means that they are just the same. The right coset that is generated using rho sub 2 and mu sub 1 are just identically the same. This means they are only counted once. This is why we do not count 5, but we still stay at 4. Okay? That is the index of h and g indicated earlier, only 4. Okay? Let me just continue and see what will happen if you have mu sub 2, meaning h mu sub 2 here. What if I have delta sub 1? That means it's h delta sub 1. And another here, delta sub 2. So you have here h delta sub 2. Okay, let's solve them one by one. So we have mu 2, okay, as our second. So rho sub 0 and mu sub 2 is mu sub 2. Take note of that. Then mu sub 2 and mu sub 2 is rho sub 0. The results are mu sub 2 and rho sub 0. So this is actually mu sub 2 and rho sub 0. This is actually similar to this first right coset. Rho sub 0, mu sub 2. So again, it's counted once. Okay, we're still at 4. How about d sub 1? Delta sub 1. So delta sub 1. Rho sub 0 and delta sub 1 is delta sub 1. Rho sub 0, mu sub 2 and delta sub 1 is rho sub 1. So delta sub 1, mu sub 1 is actually similar to this already. Okay, we have delta sub 1 and rho sub 1. That's delta sub 1 and rho sub 1. Again, similar to this already. So they are not counted differently, just counted as 1. Finally, for delta sub 2, so rho sub 0 and delta sub 2 is delta sub 2, mu sub 2 and delta sub 2, because that's mu sub 2 here, rho sub 3. So you have delta sub 2, mu sub 3. It's actually similar to this one here. Delta sub 2, mu sub 3. Okay, so delta sub 2 and mu sub, not mu, rho sub 3. So again, it's just the same as this, so they are counted as ones. So we have 4 right cosets actually. Okay, so now I would like to bring you just an additional concern here to the idea of the, because we have the same, this is the same subgroup, Okay, this is the same subgroup on the same group D sub 4. We are now on right cosets. I would like to integrate the result of the previous video, and if you would like to go with that, you might want to just simply review the results there. Okay, I'm going to compare here the left cosets and right cosets, because we also have a separate video talking about the subgroup generated by 2 and generated by 4 on Z sub 12. You might want to review those. Aside from the number of left and right cosets to be the same, we have also determined that the left and the right cosets for those specific subgroups are also identically the same. Okay, but here, let's check. If we would like to review, I'm just going to write here our left cosets, which is part of the previous video just before this one here. We have these left cosets: rho sub 0, mu sub 2. We also have rho sub 1, delta sub 2. We have rho sub 2, mu sub 1, and the rho sub 3 and delta sub 1. These are the left cosets in the previous video. Now, our right cosets here, we have rho sub 0, mu sub 2. Okay? So rho sub 0, mu sub 2. Our second right coset is rho sub 1, delta sub 1. So rho sub 1, delta sub 1. Our third is this one here, rho sub 2, mu sub 1. Rho sub 2, mu sub 1. And the last right coset is rho sub 3, delta sub 2. Rho sub 3, delta sub 2. Okay, so we have the same number, 4 and 4, because again, it's the same as the index of H and G. Now, look at the two groups of cosets. For the left, we have the same here. But for the rest of the cosets, rho sub 1 here is paired with delta sub 2. That's for left coset. Here, it's delta sub 1. These are also the same, but these two here are differently. These are not our meaning. The point here is the left and the right cosets of the same subgroup on the same group are not the same. Unlike the subgroup generated by 2 and generated by 4 on Z sub 12, where the left and right cosets are just the same. This is because our D sub 4 here is not an abelian group. Abelian means it enjoys the property of commutativity. On our addition modulo 12, the Z sub 12 group, it's an abelian group because addition in general is commutative. Here, in this sub 4, using the permutations on our Cayley's table earlier, this is not an abelian group. That is why the left and right cosets, though the same number is indicated, they are not identically the same. We have the same number, but not the same cosets. You could also determine here, just for your Cayley's table. In our previous discussion before, when we talk about groups using Cayley's table, we would know if our Cayley's table is commutative or enjoying is abelian or enjoying a commutative property if once we draw, let me erase all of this here. Once we draw a diagonal line, okay? Once we draw a diagonal line here, okay, if the upper diagonal and the lower diagonal are actually corresponding or reflections, then our operation is commutative. But as you can see here, we have these elements here and here. So they are not the same. Even if rho sub 1, rho sub 3, rho sub 1, rho sub 2, we also have this here and rho sub 2 here. Just for these two pairs, corresponding pairs, they are already not the same. Even this one here. So you would know already that this group is not an abelian group. That is also an indication that your left and right cosets should not be the same. We will have the same number of cosets, left and right cosets, but they are not the same because our group is not abelian. I'm just inserting this idea because we're already done discussing the left cosets of this subgroup in D4. Because we also had videos on, again, the subgroup generated by 2 and 4 on Z sub 12, where the left and right cosets are identically the same. So it's not all the time true. For this example, it shows that the left and the right cosets may not be the same. Just the number or the number of cosets for left and right would be the same. Thank you very much for watching.